What we're going to look at is how we can generate this exact values table. There are some angles that we can calculate really nicely without a calculator. All right, so those angles are 30 degrees, 0 degrees, 45 degrees, 60 degrees, and 90 degrees. Now, although you might say, well, what's the point in having 1, 2, 3, 4, 5 angles that I can work out without a calculator when there are so many angles in between this? These 5 angles allow us to calculate the exact values of so many more angles in our unit circle as we sort of take the ideas from the first quadrant and build from there, all right? Add that to specialist maths later on and there's a whole extra range of angles that we can work out the exact value of also. So it's powerful, it's easy, but also if you're building a house, the chances that the angle on your roof is 30 degrees or 45 degrees is pretty standard anyway. All right, these are our basic triangle shapes that we see in real world. Okay, so how do we start this? The first thing that we're going to start with is we're going to not worry about these exact values triangles, which I'll talk about next, but I'm going to go to the unit circle that we already looked at. So, unit circle looks like this. We know that each point along the coordinates here has an x value and a y value. And we know that the x value is sine of the angle. Sorry, not sine. The x value is cos of the angle and the y value is sine of the angle. We've already talked about that idea. Okay, so all of these angles here, 0, 30, 45, 60 and 90, they're all in the first part of my unit circle. They are all in the first quadrant. What do we do next? Well, let's start with the coordinates at this point. We know that that point there has the coordinate where x is 1, y is 0. So if we take from there that this is cos of 0 degrees is equal to 1. Sine of 0 degrees is equal to 0. We can start completing our unit circle. So cos of 0 degrees is 1. Sine of 0 degrees is 0. If we wrote this point in radians, 0 degrees is also 0 radians. Sweet, we've got the first part done.
What about tan?
We're not going to talk about tan just this second. This point up here, we already know on the unit circle has the coordinates 0, 1. X is 0, y is 1. So on this one, sine of 90 degrees is equal to 1. Cos of 90 degrees is equal to 0. It swaps around. What is it in radians? We know that it is pi on 2 radians. Now, what I want to try and break down here, I'm putting units here. I'm putting units here. These are angles. These are not angles, they're values. They are the measurement, the physical measurement. Remember we had the ruler out on the floor with the chalk drawing and we were measuring the length. These are lengths in the unit circle. These are angles, a measure of rotation. Okay, so what is tan? Well, there's a couple of ways we can look at tan. The first way is tan is actually the length. This is the tangent line because it is a tangent to the circle at the point 1, 0. Okay? And if I extend this point up to where it hits the tangent line, that length there is what we call tan theta. So if my angle was 0 degrees, and I was at that point there, what would tan be? It would also be 0. Okay? If I was at 90 degrees and I was going straight up there, what happens to the tangent line and my line here? What are they? They're parallel lines. Those two lines are parallel, they're never going to meet. So tan of 90 degrees is actually undefined because the two lines never meet, it doesn't work. So that's the first way we can think about tan. The other thing that we can do for tan, let's come back to this right angle triangle in here. This is my y value, this is my x value. We already know that y is equal to sine of theta, x is equal to cos of theta, correct? And we also know from right angle triangles that tan theta is equal to the opposite over the adjacent, correct? So tan theta is equal to sine theta, the opposite side, divided by the adjacent side, cos theta. If I used this to work out tan at 0 degrees, I can just do sine divided by cos. What's 0 divided by 1? 0. To work out this one, I can do sine divided by cos. What's 1? How many zeros? Can't divide by 0, it's undefined. So there's two different ways we can work out tan, but we're going to talk about that as we go forwards. Okay. They're the values that we can get straight from our unit circle. The next values we're going to get from some basic right angle triangles. So, sorry, not right, well, yes, right angle triangles, but we're going to start with this triangle. What type of triangle is this? Equilateral triangle. So this is our first triangle that helps us calculate our exact values. Why do you think I would use this triangle? How is that going to help me with this table?
Because it's 60 degrees.
It's got a 60 degree in it. It's that simple. So we're choosing, just wait for the bell. We're choosing probably the most simplest triangle that we know and connecting it to our table that we want to work with. I'm going to then also say, well, I know that all of the sides are the same. In this case, I'm going to call them 2. The reason I went for 2 is it's like nearly the easiest number I know. The easiest number would be 1. But the reason I didn't use 1 is because I'm actually going to split this equilateral triangle into half. So that side would still be 2, same as that. Probably shouldn't put a little dash. This side, if I've split it in half, is now what? 1. What's this angle?
30.
30. So we now have a triangle that's got 30 and 60 and some pretty simple numbers. We're going to add one more number over here using Pythagoras' rule, which says that a squared plus b squared equals c squared. Let's call this a. We don't know what that side is. This side's 2. Bit of Pythagoras' rule, b squared equals 2 squared minus 1 squared. B squared equals 3. B equals plus or minus the square root of 3. Because when I solve this problem, I always get a plus or a minus. But can I have a minus length? No. So it's just going to be positive root 3. This is root 3. Okay. We get that. That's basic mathematics, isn't it?
Yep.
All right. It's equilateral triangles, splitting it in half, Pythagoras' rule. Let's use some other basic mathematics that we know, which is SOHCAHTOA. So sine of the angle is equal to the opposite divided by the hypotenuse, correct?
Yeah.
So if I did sine of 60 degrees, sine of 60 degrees is the opposite, root 3, divided by the hypotenuse, which is 2. Sine of 60 is root 3 divided by 2. let's do sine of 30 degrees. Sine of 30 degrees is the opposite divided by the hypotenuse. 1 divided by 2. Sine of 30 degrees is 1 divided by 2. Do the same for cos. Cos of 60 degrees. What's cos? The adjacent divided by the hypotenuse. So cos of 60, the adjacent, 1 divided by the hypotenuse, 2. Cos is 1 over 2. What is cos of 30 degrees? The adjacent, root 3, hypotenuse, 2. And you will notice, as Con just said, it's the opposite of sine. And that's one of the trig rules that these will be, can't remember the name of the rule, but basically sine and cosine are opposites of each other over 90 degrees. So cos of 20 degrees is equal to sine of 70 degrees. Okay, we could use still this triangle and do tan. What is tan? Tan's the opposite over the adjacent. So tan of 60 degrees. Tan of 60, opposite over the adjacent. Root 3 over 1, which is just root 3. Tan of 30 degrees is 1 over root 3. Oh, that's a 3, would you believe? All right, we've got most of our table complete from one triangle. Add in the radians. Now you could convert using the formula, or you can go back to the unit circle and we can just think, okay, we know that this is 0 radians, pi radians, 2 pi radians. If I broke that up into 6 equal parts, this was 180 degrees, wasn't it? Yeah. So 6 equal parts, just waiting for the bell. This would be 30 degrees, wouldn't it? Yep. Or it would be pi divided into 1, 2, 3, 4, 5, 6. 30 degrees is pi divided by 6. 60 degrees, well, that would be 2 lots of that, wouldn't it? Yep. So it's 2 lots of pi divided by 6, which is pi divided by 3. Oh. All right. You just got the 45. We will keep working on these radians and stuff in the next lesson, but we're just building up. Now we've got 45. Let's do the unit circle and work out the radians first. So 45 degrees is exactly halfway, isn't it? Yep. Or if we took pi and we divided it into 1, 2, 3, 4 equal parts, this is pi divided into 4 equal parts. It's like pi over 4. We say pi over 4. It's not some magic number. It is literally a distance of 3.14 around the unit circle divided into 4 equal parts. Okay. 3 more bits to go. How does it work? Where does it come from? To find the other exact values, we're going to use this second basic right angle triangle. Anyone know what we call this right angle triangle? Equilateral right angle. Close. It's written on the board. Isosceles. The following right angled isosceles triangle. Now, hang on. Same thing. We're just going to work with some basic numbers. If this is an isosceles triangle, it means those 2 angles have to be the same. And because the angles in a triangle add up to 180 degrees, they have to be 45 degrees. Because 45 plus 45 plus 90 make 180. Not magic, basic internal angles of a triangle. Let's start with the easiest number that we know, 1. 1. Let's use Pythagoras to find out the long side.
Root 2.
And we don't get the minus value because it's a length. So this is root 2. Now I'm going to do sine, cos and tan of 45 degrees. I don't need to know both of the 45s. I'm just going to pick one of them. I'm going to choose this 45 down the bottom. So sine of 45 degrees equals the opposite, 1 over root 2. The opposite over the hypotenuse. Cos of 45 degrees. Funny enough, it's the same. Adjacent over the hypotenuse. And tan of 45 degrees equals 1 over 1, which is 1. So tan of 45, 1. Sine of 45 is 1 over root 2. I'm not going to write it down just yet. I'll tell you why in a moment.
I just wrote it.
That's okay. You can adjust. It'll be all right. First thing, this makes sense. And I'll show you why it makes sense. Here's my hand-drawn circle. I'm not going to suggest for a moment that it's perfect. All right? It's not too bad. 45 degrees has to be exactly halfway. So I'm going to guess that that's about 45 degrees there. And remember, the tan line runs parallel to the y-axis. And I think, where does this hit tan? Now, even in my hand-drawn circle, you can see that it's basically the same spot as that, which was 1. So tan of 45 degrees equaling 1 makes sense because the circle's perfectly symmetrical. All right? That's tan of 45. Why didn't I stop here? Who remembers from advanced maths rationalising the denominator when you did surds? Yes? In maths methods, we don't want to have a denominator that is an irrational number because you can't divide by root 2. What's like root 2 is a decimal that goes on forever with no breaks. So how do you divide by a number that goes on forever with no breaks? You can't do it. So what I do is I rationalise the denominator. The way I rationalise the denominator is I multiply both the numerator and the denominator by whatever this is. Because effectively I've multiplied it by 1. All right, that's the same as multiplying by 1, isn't it?
Root 2 over root
So it
2
becomes
squared.
root 2. And what is root 2 squared?
Root 4.
It's 2.
It is 2. Because the squared and the square root cancel each other out. So this one becomes root 2 over 2 as well. So this is like, simplifying fractions. If you don't simplify fractions in maths methods, you lose a mark. If you do not rationalise denominators in math methods, you lose a mark. In specialist maths, because we've got some specialist maths people, you don't have to rationalise the denominator. Bonus, actually.
That's good.
All right. So this one also has an irrational denominator. So rather than writing 1 over root 3, we're going to multiply it by root 3 over root 3, which becomes root 3 on 3. That is a better answer for maximising your score. Now, the other reason for showing you that, and the reason I said don't do this in your summary journal straight away, is I'm going to change some of these numbers to help you memorise this table. Our goal is to be able to recite the exact values. You're expected to know this off the top of your head, or at least work it out without any notes. And it's easy, easier than you might think. This is how it works. From here, I'm going to rewrite that as the square root of 0 over 2. Why? What's the square root of 0? 0. What's 0 divided by 2?